Okay, so this is a lab 1 report presented by Xinyu Gong. And for this charge type experiment, I'm gonna go through the introduction and fundamental theorem, the experimental process, microscope analysis, and the final evaluation about the what if and why question. Neutral objects can acquire excess negative charge or deficiency of negative charge if they are rubbed, pulled apart, or even just touch other objects. And this estimated excess charge on tape about 8 inches long will be between negative 1.6 times 10 to the power of negative 19 to 10 to the power of 5 coulomb. We're doing this experiment to measure the exact value inside the range for a given length of plastic tape. And the fundamental theorems applied in this experiment are charged objects of neutral objects and similar charges repel, and the equation to calculate the electrical force for a given charged object, and the momentum principle, which implies when momentum keeps constant, there's no net force. So here's the steps of my experiment. Place a base tape about 20 centimeters long on the table. Make 2 U-tapes by attach and remove it from the base tape, and move my hand close to check if it is charged. Place the upper tape on top of 2 books and slowly move the bottom tape towards it until the upper tape floats. Then carefully measure and input the mass of tape, the separation distance at which the top tape begins to float, which is about 0.011 meter. Here are the assumptions of my analysis. Firstly, assume that each U-tape has the same net charge evenly distributed, as they are equally long and created from the base tape of same material and length. Secondly, treat each tape as if all its charge were located at a single point at the center of the tape to simplify this model. Thirdly, ignore air resistance of the moving tape since it is moving really slowly. Here's the free body diagram for this experiment. The momentum of this concentrated charge keeps constant, so the net force in the y direction, which has components of the electrical force and gravitational force, will add up to 0. Here's the result of my experiment. By inputting the mass of the tape, we can calculate the gravitational and electrical force of the object, which is about 1.96 times 10 to the power of negative 3 Newton. And using that force, we can find the total charge for the base tape, which come out to be 5.13 times 10 to the power of negative 9 coulomb. And the total number of charge efficiency will be 3.2 times 10 to the power of 10 approximately. This is the answer for the what if question. By observing the attraction between U-tapes and negatively charged plastic pen, we can know that the tapes are originally positively charged, showing a deficiency of electrons. So if electrons carry positive charge, the U-tape should now bring negative charge with it instead of being positively charged. But the tape will still repel each other and make the top tape float because both charge now are negatively charged and similar charge repels. And for the why question, we have to handle the tape as little as possible because our hand is inherently neutral. So if we keep in touch with the tape that lack of sufficient electrons, the electrons of our hand will move to the tape and make it neutralize. So the observation result will be disturbed, and the same reason applies for all other neutral and charged objects. Thank you.